Hi dear friends and viewers, welcome back to our channel Anvil Kumar Basics of Physics. This is the right place to learn. Dear friends, in this video we are going to discuss about the one of the most important topic, that is the first law of thermodynamics in thermodynamics chapter. Clear? This is the very important and useful for the next topics. That's why watch very carefully. What is mean by first law of thermodynamics? First law of thermodynamics is the conservation of energy in thermodynamics, and it is purely concept of the internal energy. Okay, now the statement, what is the statement of first law of thermodynamics? The amount of heat supplied to the system that should be equals to the sum of the internal energy and work done by the system against the surroundings. That should be what we call first law of thermodynamics. Here statement is there, watch very carefully. Heat given to a system is equals to the sum of increase in internal energy and the work done by the system against the surroundings. That is dq is equals to du plus dw. Here what is dq? dq is the heat supplied to the system. Heat supplied to the system. And what is du? Change in internal energy. Change in internal energy. And what is dw? Work done by the system. Work done by the system. Clear? So this is the simply about the first law of thermodynamics. dq, heat supplied to the system, equals to what? Sum of change in internal energy and work. This is what we call first law of thermodynamics. Dear students, I will give one example for you, very simple example, what we can find in our daily life. For example, it is a gas stove that we are having some burner like this. On that one we are keeping some, here one container is there or one vessel, water may be there, and on that one we are having some lid, it is the lid. Clear? And that container should be having some water. Clear? We are giving the heat, that means what? Simply we are dq, that is. Clear? While we are heating the water, what you can observe, the temperature of the water is going to be increase. Clear? That increase in temperature is nothing but change in internal energy. Change in internal energy. How it is takes place? For example, to understand simply, here I am drawing some molecules of water. Clear? The molecules which can absorb the heat, that is going to be excited. Clear? So when it is heated, temperature is increases. When temperature increases, density decreases. What it is? Density is decreases. Clear? Temperature is increases, density is decreases. That's why it becomes lightweight and that should be goes to the top. During that process, the molecules will make some collisions with the other molecules in that particular container. Clear? Watch very carefully. The molecules which can absorb the energy, they are going to be excited and they want to go to the top of the water. That's why here simply they are moving from bottom to the top. During that process, they will make some collisions. During the collision, the heat may be transferred from one molecule to the another molecule. Due to that, the molecules all are going to be gets heat. So the increase in temperature is why? Because internal energy. What it is? Internal energy. The molecules which can absorb the heat, they are wants to goes to the top of the fluid. During that process, they can vibrate, they can oscillate, and they can move. That's why during that process they will make some collisions with all the molecules. The molecules all are taking the energy during the collisions. Due to that, all the molecules is going to be gets temperature. That's why what you have to say simply, the rising or falling in temperature is nothing but change in internal energy. The internal energy can be defined as simply sum of internal energy. Internal energy, it is the sum of the, look here, internal energy, it is sum of the simply kinetic energy and potential energy. Kinetic energy and potential energy. The molecules are moving from one place to the another place. That's why they have some kinetic energy. Again, that kinetic energy should be classified like this: vibrational kinetic energy, vibrational kinetic energy, and rotational kinetic energy, rotational kinetic energy. Simply, what we call internal energy is nothing but sum of vibrational kinetic energy, rotational kinetic energy, and potential energy. That should be what we call internal energy. So dear students, that internal energy is not depend upon the path moving. Simply that should be depend upon the initial and final positions. So internal energy is not depend on path of moving, on path of moving. Simply that should be depend upon initial state and final state. Clear, children? So this is simply what about, children, dq amount we supplied, due to that some changes occur, that is what dq du, and due to that simply here when the molecules are going to be gets heated, they can convert into the vapor. The vapor is wants to remove the it makes to fly the lid. The lid may be fall from the container. That's some work. Clear? The water is going to gets heated, that should be converted to the steam. The steam can pushes the lid in upward direction. That is the amount of work done by the liquid. So for example, we are supplying some 200 joules of heat to that water. In that, here 120 joules are gets converted into the internal energy, and remaining 80 joules are can be used to push that particular lid. That should be simply what about we are going to discuss, that is the first law of thermodynamics. 200 joules are we are given. In that, the entire fluid is going to be increase its temperature because of 120 degrees Celsius, 120 joules of heat is transferred to the water, and remaining 80 joules can be used to do some work. That work what is simply that is going to be lift the lid of the particular container. So this is a way to simply understand what about the first law of thermodynamics. And what I told you, internal energy is the main concept of first law of thermodynamics, and internal energy is not depend of the path moving. That should be depend only initial and final stages. Initial and final stages only. Final stages only. So this is simply about the first law of thermodynamics, children. Here now you have to remember the first law of thermodynamics can be have some sign convention rules, and there are some limitations also there here. First we are going to discuss about the sign convention rules to use the first law of thermodynamics. When heat supplied to the system, then dq is taken as positive. Clear? When heat supplied to the system, dq is taken as positive. When heat is taken or drawn from the system, then dq is taken as negative. Clear? And next thing is, when we can take du is positive and when we can take du is negative. When temperature increases, temperature of system, think about this, temperature of system is increases, then du is taken as positive. So temperature of system is decreases, then du is taken as negative, children. And then when we will take dw is positive, when we will take dw is negative. So for that, simply here, if system can do work, that should be taken as dw is positive. So it means what? For example, if a container is there, in that container some gas it is there, that gas is doing some work. What it means? The gas is going to be expand. Gas is going to be expand. System can do work. It means that dw is positive. When it is possible, that means here simply expansion of gas or liquid should be takes place. Expansion takes place. When system can do work, it is going to be expand, then the work is positive. And if system work is done on the system, work is done on the system, then it is going to be, work is going to be taken as negative. Why? Because in this case the fluid or the gas may be here going to be compress or contract. Clear? So these are the sign conventions when we will take or when we are using the some first law of thermodynamics. During the any problems you have to understand these things. So this is about the main thing is limitations. What are the limitations here? Limitations of first law of thermodynamics. So what it is? The first thing is here, this law cannot explain direction of heat flow. That means in which direction the heat is moving. It does not explain by the first law of thermodynamics. This is the main demerit of the first law of thermodynamics. What it is? Heat does not, first law of thermodynamics cannot explain the in which direction it is moving. And the second thing is here, under what conditions heat is converting into the work. Under what conditions? Okay, dq is equals to du plus dw, it is right. But how the heat is converted to the work? Under what conditions? He was given any explanation about that one. And third one is, there is no explanation about the why 100% heat is not converted to the work. Third one is what? Why, how much heat we are supplied to the system, why it is not completely converted to the work. So these are the main demerits of the first law of thermodynamics. First one is what? It does not explain the in which direction it is moving, and it does not explain the under what conditions it is going to be converted to the work. And third one is the law is not given explanation about the how whole heat what is supplied that should be not converted into the work. So children, this is about the information about the first law of thermodynamics. So I hope you understand. If you can understand this one, like, share, comment the video and subscribe my channel to get all notifications, and suggest my channel to your friends also. Thank you for watching.